Chapter 1.1, identify points, lines, and planes. So the definition of a point has no dimension. It is represented by a dot. So right here, this is a point, and it's labeled with a capital A, so you just name it point A. You name it using one capital letter. Definition of a line has one dimension. It is represented by a line with two arrowheads, but it extends without ends. So this here is a line. Okay, it extends forever in each direction, so it extends forever going that way, and it extends forever in the opposite direction as well. So to name the line, you name the line using two capital letters, which are any 2 points on the line, with this symbol on top of the two capital letters. Okay, the order of the letters doesn't matter, so let's take a look. So on this line here, we only have 2 points on this line, so we can call this line AB with the line symbol on top, or you can say BA with the line symbol on top. Okay, any 2 points on the line, any order. The order doesn't matter. Alternatively, you can use one lowercase letter, but that lowercase letter is not a point. So if you look at this line here, we can see right here, this is a lowercase l, okay? So we can also name this line L. So you can say line L, you can say AB or BA with the correct symbol on top. Definition of a plane has 2 dimensions. It is represented by a shape that looks like a floor or a wall, but it extends without end. Okay, so here is our plane. It's represented by a flat sheet. Okay, basically you have to imagine a flat sheet of paper that extends forever but remains flat. Anyhow, you can name this using 3 capital letters, okay? You have to use 3 points that are not on the same line, or you can use 1 capital letter that is not a point, okay? So in order to name this plane here, we can say ABC, and really the order of the letters doesn't matter. Okay, so you can say BAC, CAB, and so on. Okay, no sense in writing out all the combinations. The order of the letters doesn't matter. Or you can use this letter M right here. That's not a point. So you can say plane M. All right. So 3 letters that are not on the same line, or just say plane M. Okay, so you want to remember through any 2 points, there is exactly 1 line. So if you have 2 points, there is only 1 line you can draw through those 2 points. Okay, so that's all they're saying. Okay, through any 3 points not on the same line, there is exactly 1 plane. So if you have 3 points in space, there is only 1 plane that will fit those 3 points, okay, as long as they're not all on the same line. So imagine these points are on the screen, and then imagine the screen as a plane. So as long as they're not all on the same line, there's only 1 plane that fits 3 points. All right, collinear points are points that lie on the same line. So that is easy to remember because the word line is in the word collinear. So collinear points, remember, same line. Coplanar points are points that lie on the same plane. Okay? Same plane is easy to remember because the word plane is in the word coplanar. So remember, collinear, same line. Coplanar, same plane. Example 1, give two other names for line PQ and for plane R. Let's take a look. All right, here's point P, here's point Q. So this right here is line PQ. Okay, remember we said the order of the letters doesn't matter. So instead of PQ, we can also write QP with the line symbol on top. The other way is to use the one lowercase letter, which is right here. Okay, so we can also say line N. Now for plane R, the other ways to name plane R, you want to use 3 points that are not on the same line. So you can't use SP and T together. So you can say VSP. You can say VST. You can say VPT. Okay, all 3 of those work, and you can even mix up the letters within each one. So as long as the points are not all on the same line, you're fine. Okay, part B, name 3 points that are collinear. So collinear means that the points are all on the same line. So if you look at this line right here, we have points S, P, and T all on the same line. Also, they want us to name 4 points that are coplanar. So if you look at the plane represented by this sheet that's in pink or red, you just pick 4 points that are on this plane here. So we can say points V, S, P, and T. Okay, they're all on this sheet right here. So V, S, P, and T. Now, one other way to do it, if you imagine a plane that's straight up and down, imagine the screen that you're looking at is a plane. We can say points Q, S, P, and T. So that would be Q, S, P, and T. All right, guided practice number 1. Use the diagram in example 1. Give 2 other names for line ST. Let's take a look. All right, so here's line ST. See if you can come up with at least 2 other names for that line right there. Okay, remember we said we can reverse the letters for the line. So line ST can also be called line TS with the line symbol on top. Okay. Also, you can choose any 2 points on this line. So we can also say SP with the symbol on top. We can say PS with the symbol on top. We can say PT. We can say TP. And also, we can say line M. So there are a lot of ways to name line ST. You can choose any 2 points. The order doesn't matter. Okay, part 2, I want you to name a point that is not coplanar with points Q, S, and T. Let's take a look. So see if you can find a point that is not coplanar with points Q, S, and T. Okay, QST, if you imagine that the screen is a plane, okay, imagine the plane that's going straight up and down, QS and T would be on that plane, and so is point P. Okay, however, if you look at point V, that is out in another direction. So the only point that is non-coplanar with QS and T is point V. Okay, point V is the only one. Point P is coplanar with QS and T, so point P would not work. And R is not even a point. Okay, definition of a segment or line segment. I like to think of it as a piece of a line. Okay, so the line segment AB or segment AB, written as AB with a bar on top, consists of the endpoints A and B and all points on line AB that are between A and B. Note that AB can also be named BA. So let's take a look. So this is a segment or line segment. It's just a piece of a line. Okay, you name it using 2 capital letters, which are the endpoints, with the bar symbol on top. So this line right here, you can say AB with the bar on top, or you can say BA with the bar on top. Same thing, but you need to use the endpoints when naming a segment. It's not like the line where you can use any points to name any points on the line to name the line. Okay, ray definition. The ray AB, written as AB with this symbol on top, consists of the endpoint A and all points on line AB that lie on the same side of A as B. Note that AB and BA are different rays. All right, so you want to remember for the ray, it extends forever in one direction. Okay, I like to think of the ray example as like a ray of sun. So the sun would be the endpoint, and then the sun ray extends forever in one direction. So for the ray, you name it using 2 capital letters with this arrow symbol. Okay, the endpoint letter is always first, and the second letter is any other point on the ray. All right, so let's take a look. So these right here are actually 2 different rays. Okay, you see the endpoint right here? That has to be the first letter. And then the second letter is any other point on the ray. So the only other point on this one is B. And then you have to put this symbol on top. Okay, so this ray right here, it starts at A and then it goes forever in that direction. Now this ray on the bottom is different. Okay, this endpoint is B. So we have to start with the letter B. And then we use any other letter on the ray. In this case, the only other letter is A. And again, we need to use this symbol on top of the 2 letters. Okay, so notice even though the ray points to the left, the symbol on top of the 2 letters points to the right. So this ray right here, it starts at point B, and then it goes forever in that direction. Okay, it says if point C lies on line AB between A and C, then CA and CB are opposite rays. Let's take a look. So right here, we have point C, okay? That's between points A and B. So the first ray, it starts at C, and then it continues forever to the right. And then the other ray starts at C and continues forever to the left. All right, so the one that's pointing to the right, it started at C, and then the only other letter on that ray is B. And let's see, the one that's pointing to the left, it started at C, and then the only other letter on the ray is A. So CA and CB are opposite rays. So for opposite rays, when you put them together, opposite rays make a line, okay? And they must have the same endpoint. So like we just did before, okay, they both start at point C. All right, and together, when you add the one that's going to the right and the one that's going to the left, you have a line. As you can see, when you put them together, you have a line. But they have to have the same endpoint. All right, example 2, give another name for line segment GH. Let's take a look. All right, here we have GH. Okay, I'll highlight it real quick. It starts at G and it ends at H. So it's just this piece right here. That's it. So GH, line segment GH, is written like this with the bar on top. But another name for it would be HG, because the order of the letters does not matter for the line segment as long as you are using the endpoints.
Good morning, Mac.
Part B, name all rays with endpoint J, and then which of these rays are opposite rays. Let's take a look. Okay, if they want us to name all rays with endpoint J, that means all of the rays are going to start with the letter J, because you always start with the endpoint letter. So the ray that is going to the right, that is going to be JF. And the ray that is going to the left, that is going to be JE. Okay, notice I put the correct symbol on top. And the ray that is going up, that's going to be JG. And the ray that is going down, that is going to be JH. So again, notice the symbol on top always points to the right, even if the ray doesn't point to the right. Now, for the rays that are opposite rays, you want to see which ones form a line, okay? And if you look at JF, which goes this way, and JE, which goes this way, those two form a line. So these two rays right here are opposite. Okay, and now if you look at the other set, JG goes up basically and JH goes down. So these two together also form a line, and they have the same endpoint. So those rays are also considered opposite. But notice that all of the rays that I named start with the letter J, which means they all started right there. That's the end point. Okay, let's try guided practice number 2. Give another name for line segment EF. Let's take a look. All right, so use the diagram and find another name for line segment EF, please. Okay, for the line segment, we said we can reverse the letters. So E and F are the endpoints. We can also say FE with the correct symbol on top. Okay, we didn't really even need the diagram for this problem because we know if EF is a line segment, then you could just reverse the letters and say FE. Okay, part 3, or guided practice number 3, are HJ and JH the same ray? Are HJ and HG the same ray? Explain. All right, let's take a look. All right, so using the diagram, tell me if HJ and JH are the same ray or HJ and HG are the same ray. Please try that one. Okay, so as far as HJ and JH, the answer is no, because they have different endpoints. All right, without even looking at the diagram, I can see this one starts with H and this one starts with J. So there is no way those could be opposite rays. And if you trace each one, HJ is like that. Okay, and JH starts at J. JH is like that. So those are different endpoints, and they cannot be opposite rays with different endpoints. I meant to say they cannot be the same ray with different endpoints. Okay? They have different endpoints, and not only that, HJ goes up and JH goes down. So they're different endpoints, and they're also in a different direction. So the answer is definitely no. Okay, let's look at HJ and HG. HJ starts at H and it goes forever toward J. And then if you do HG, HG starts at H and it goes forever toward G. Okay? So it's the same ray. So the answer is yes, because they have the same endpoint. And also the same direction. So the first one was no, the second one was yes. All right, so the intersection of two different lines is a point. Okay, so intersection just means where they meet, and you can see they meet right there at point A. The intersection of two different planes is a line. So you can see the plane here in pink or red, and the other plane is in blue. They crisscross or meet right here at line Q. Okay, so when the planes intersect, they always intersect at a line, never just a point, because the plane extends forever. So the plane has to intersect at a line, not a point. I mean, two planes have to intersect at a line, not a point. Example 3, sketch a plane and a line that is in the plane. Okay, so for part A, here's the plane right here, and the line is actually in the plane. Part B, sketch a plane and a line that does not intersect the plane. All right, so here's part B. We have plane M, and then we have line L. They do not intersect. Okay, you basically have to imagine this in 3 dimensions, and the plane would be behind or in front of the line, and they would never intersect. Remember, the plane stays flat. It is not 3-dimensional, it's 2-dimensional. Part C, sketch a plane and a line that intersects the plane at a point. So right here, you have to imagine in 3 dimensions, the plane is going from front to back, and the line just goes right through that sheet. So it only intersects at a point. All right, example 4, sketch two planes that intersect in a line. All right, so that's what that would look like. They drew the one in green, basically straight up and down, and the one in blue is going from front to back. And this portion right here is the line where they meet or intersect. Okay, let's try guided practice number 5. Using the diagram, name the intersection of line PQ and line K. Let's take a look. So please try that. Intersection of line PQ and K. All right, here is line PQ. And here is line K. And clearly, we can see they meet at that point right there. So that point in the middle where they meet is point M. Okay? So the intersection is point M. Number 6, name the intersection of plane A and plane B. Let's take a look. Okay, see if you can figure that out for plane A and plane B. All right, remember when 2 planes intersect, they intersect at a line. Okay, so plane A is this one going left, right. Plane B is going up and down. So where they meet is this line right here. So there are not 2 points on that line. Okay, there's only 1 point M, so we can't use that. We have to use line K. So these 2 intersect at line K. All right, last one. Name the intersection of line K and plane A. Let's take a look. So here is line K, and here is plane A. So please try that one. All right, we can see that line K is actually on plane A. So the place where they meet is not a point. Since line K is actually on plane A, that line is the intersection. Okay, so line K and plane A, they actually meet right here. So the entire line K is the answer.